All right. So the next step we need to know for systems is to figure out the number of solutions. So how many solutions, how many points of intersection are there in a system of linear equations? So this sounds really obvious because a lot of you are going to think, well, if I have two lines, if I draw two lines on a graph, 1, 2, there's going to be one intersection, right? That is one possible answer. There's actually two others. So I'm going to draw a line here like this, and I'm going to draw a line like this. Okay, let's say these are parallel. If they're parallel, they're never going to cross, which means this would have 0 points of intersection. Okay, there's one other instance where this can happen. I'm going to draw a black line right here. Let's use my ruler so it's easy to see. Okay, yep, that'll work. That is my line. And then I'm going to draw a different equation right here, the red one. Okay, as you notice, the red and black lines are overlapping each other. So how many times do they touch each other? Infinite number of intersections. Okay, so those are the three types of answers we can get. Oh, sorry, one was just like that. These are the three types of questions we can get. Now, looking at these examples, we want to try and figure out how, if it has a graph, it's really easy to see, using an equation, how we can see these working. So let's actually do this one first, because we said these have the same slope. So in an equation, we need to be able to write two equations that have the same slope. So let's look at the first one. Let's say y equals, let's just say 2x plus, 4. Okay, looking at this equation, the slope is whatever's in front of the x, so the slope is 2. So if I wrote another equation, the slope, if I want them to have 0 points of intersection, the slope has to be the same. Now, the y-intercept, the number at the end, has to be different. If it's the same, they'll actually be overlapping. So when I look at this, these two equations have the same slope, which means they're parallel. So if you ever have a situation where you have two lines and the slopes are the same, but the y-intercepts are different, that means you're going to have no points of intersection. Okay, so that is same slope, different y-intercept. Now, the infinite slope one, let's do this equation. We'll just call this one y equals x. Okay, that is the equation of that black line. I want to change this equation. So what I'm going to do is I'm going to multiply it by 2 on both sides. So 2y equals 2x. That is the equation for the red line. If I graph that, I could simplify it to y equals x, which is the same. When you have two equations which simplify to be the exact same thing, that means they will overlap. And that means that there are infinite solutions. The last one is basically anything else. So if you have an equation, let's call this one y equals, 2x plus 1. And then the second equation, as long as the slope is different, so let's call this one, negative 2x plus 4. As you notice, different slope and different y-intercept. Different slope and different y-intercept. To be honest, the y-intercept can be the same and it doesn't really matter. They just have to be different slope. Because for example, if I did this, say the y-intercept was 2, those two lines have the same y-intercept, but because they have a different slope, they have 1 point of intersection. And the slope doesn't always have to be negative. So for example, you could have this. This slope is positive, this slope is positive, but they still have a point of intersection. So if you're given two equations, like y equals 3x plus 4, y equals 3x plus 7, you need to be able to tell how many points of intersection will this have. And notice these are the same slope, they're parallel, so this is going to be 0. So if I change this to be this, we would now notice they're the exact same equation, there would be infinity. And then if I change this to be, 8x, now I would know there is 1 point of intersection. And that's it.